Hi, I'm Lilian Grace Gamayot, and for today's video, I'm going to show you my output proposal for CE 540 class or Work Integrated Learning or OJT. So first, let's start with activity 1. So in activity 1, we were asked to investigate the house if it conforms with the National Building Code of the Philippines and have it redesigned so that it conforms with the National Building Code of the Philippines. So first, this is my compliance report for the investigation that I did. So in item number 1, it says that the setback from the property line is lesser than the minimum requirement. So in National Building Code of the Philippines, it's stated there that there shall be at least 2 meter space between the structure and the property line. So we can see in the figure 1, we have here the documentary evidence of the non-conformity of the National Building Code to the National Building Code rather. The property setback is only measured at 1.82. Hindi siya ganun kalaki, hindi po siya ganun kalaki yung ang kulang, but then again, hindi siya umabot sa 2 meters. So, hindi pa rin siya pasok sa standard. And then we have the entrance door dimension is slightly lesser than the requirement. So the requirement is every required exit doorway shall be emphasized to permit the installation of a door of not less than 900 millimeters in width and not less than 2 meters in height. So in figure 2, 2A and 2B, we can see here that the entrance door with only measure at 0.86. In the bedroom door, 0.7 meter. And the height for the bedroom door is only at 1.8 meters. So, again, hindi siya ganun kalaki yung kulang, but then again, hindi pa rin siya pasok sa proper standard. Hindi pa rin siya pasok sa standard measurement or standard dimension na hinihingi. And then we have here, the column does not meet the required standard. The column shall be at least 250 by 250 millimeters in dimension. Yet the house has only a column dimension of 200 mm by 200 mm. So in dimension. And then the lack of kitchen, dining area, and the lack of comfort room. So to clarify this one, this house that I chose to investigate is the owners have been planning to have it renovated, and some of its part is sinira na or giba na, kaya pasok din siya sa non-conformity kasi wala na siyang comfort room or comfort room and dining area. And then we have lacks of roof drainage system. Roof drainage shall be installed at low points of the roof and shall be adequate in size to discharge all tributary water. So we can see here in figure 5 na wala siyang gutters, wala siyang flushing lang siya diretso. So that's all the non-conformity that I found while doing the investigation of the house. Then let's proceed to the architectural plans because it's part of activity 1. So again, in activity 1, we were asked to investigate a house and have it redesigned so that it conforms to the National Building Code of the Philippines. So since the owner of the house has been planning to have it renovated, that's one of the reasons why I chose this house as a model for my OJT proposal. Because it will give me the opportunity to highlight my skills in designing a house and ensuring that all the elements conform with the National Building Code of the Philippines. So, yun. So first, let's look at the original house layout. So this is the original perspective, or this is the original version of the house. Typical. And then we have here the original floor plans. We have the living room, 2 bedroom, with a dimension of 2.7 by 3.1, both symmetrical sila. And then this used to be the kitchen and toilet bathroom area. Wala na since sinira na nila because they've been planning to have it renovated. And then we have here the front elevation plan, right elevation, left elevation, and rear elevation plan. So now let's proceed to the proposed one-story residential building na ito na yung bagong itsura. Ito na yung bagong layout ng bahay. So this is the perspective. Then we have here the vicinity and the site development plan. This property or this project is located at Sinuda Hitaw, Bukidnon. So along the highway lang siya. And then here is the new room. The bedrooms. In-split ko lang yung bedroom 1 and bedroom 2 para ma-insert itong toilet and bathroom area. Then we have here the kitchen and the lanai. So this is the proposed floor plan and the original layout. Then we have here the left elevation plan and the front elevation, the rear and the right elevation, cut section through AA, cut section through BB. Dito yan sa floor plan nakikita. So we have here the cut section AA and the cut section BB. Then we also have the schedules of doors and windows and the working drawing. So these are the complete architectural plans. So that's all for activity 1. Now let's proceed to activity 2. In activity 1, kasali dun sa task is to have a vlog documentation while doing the site investigation. So this is my vlog documentation. I will put the link in the description box below para makita ito.
This is my
So now that we're done with activity 1, let's proceed to activity 2. So in activity 2, we were asked to design for the structural elements of the house. So first, ito po yung rendered structure in STAAD. And then we have here the computation for loadings na in-apply ko sa structures sa STAAD. So all the factors and loads are based from NSCP 2010. So we have the dead loads, live loads, wind loads, and the seismic parameters. So for wind loads, 150 kPa, ako ang gigamit na basic wind speed since the project is located at Bukidnon. So here in NSCP 2010, makita nasa zone 3, ang V is 150 kPa. So included ang Bukidnon. So since ang area sa project is in Bukidnon, 150 kPa akong gigamit. So we have here the zone 1, zone 2, and zone 3 sa roof ni siya. And then dili na ka na siya dito. So since the roof has a 7 to 27 degree in slope on degree, so sa slope niya, kanya ko ang gigamit na values. So for zone 1, under 150 kPa, so for effective wind area, zone 1, is ang effective wind area niya is ang effective wind area niya is 3.63. So kanin si 3.63 po is di rin siya gikan sa truss for truss o what sa trust spacing times 1/3 sa span. So we have 3.63. Then, gipangita lang nako ang values sa, since ang effective area sa purlines is 3.63, na-fall siya sa zone 1 diri as a 2. Wala man siya ni-out of 4.5. So, gitabulate lang nako ang 0.39 ang iyahang negative values. We have here 0.39 negative values. Then again, for zone 2, ganun pa din, 0.39 and negative 1.10. And then for zone 3, we have 0.39 and negative 1.65. After that, para makuha ni siya ng mga values, times lang, multiply lang ako ang 0.39 sa purlin spacing, since sa purlins pa man effective area ang ginakuha for the wind loads. So, mao na siya nakakam up kung inana na nga mga values. Same lang din po siya sa trust, sa trust na wind loads. Ganun lang din yung pagkuha. But instead na per lanes, sa pagkuha sa effective load, instead na, pagkuha ani ng mga values, instead na sa per lanes spacing nimo ay i-multiply sa trust spacing na or siya multiply. So that's for the computation of values. And then we have here the seismic parameters. So kani siya is nakuha na ko siya sa using Hazard Hunter. So the nearest active fault niya is 25.8. Ang location niya is Sinuda, Kitaw-Taw, Bukidnon. Seismic zone 0.4. Occupancy category is 4. Then we have the soil profile types as D, the seismic source type D, seismic importance factor 1, and then near force factor NA and V is 1. And then we have seismic efficiency A 0.44, seismic efficiency 0.64, and we have numerical coefficient or R 8.5. So, nana siya maibot ang gi-apply na ako sa STAAD. We have here the loadings. So, for live loads, dead loads. Then we have live loads. For the wind loads, ini siya. And then, wind load 2. Mao na ni siya katong dirian na values po. No. Kaniya siya katong, this is for wind load 1, positive values. Okay. Ito siya. Pero negative siya diri kay pabaliktad ng loadings. Then we have here katong negative values na nakuha natin sa wind loads po. And then the seismic parameters. And then the load cases. So that's all, and then run analysis. So now that we already have a available data na since tapos na sa STAAD, let's proceed na sa beam design calculations. So first, gitabulate na ko na siya tanan na values from on STAAD. Then, i-identify po na ang maximum and minimum moment na values para magamit siya sa beam design calculation. So now let's proceed here. So this is beam design calculation for beam 21. So for the left span top, this is the parameters. We have MU 5.243. Muna siya po ang minimum value, maximum na, the minimum value for moment, negative 5.24 sa top shot. And then we have span 3.7, strength parameters, FC and FY at 21 and 275 MPa. Ang gigamit po na refer is grade is grade 40. Then we have the dimensions, 300 by 200 mm, the concrete cover 40, and the rebar 12 mm in diameter. Ako ang gigamit for the beam designs. So these are the solution for the designs. We have T is equals 244. We have Rn is equals mu over the reduction factor d squared. Rho at 0.85 Fc over Fy. Was from 1 minus square root of 1 minus 2 Rn over BFC is equal 0.0018. We have round max at 0.14588 and then round mean 0.00509. So to check for if it's singly or doubly reinforced, if the row is less than round max, therefore it is singly reinforced. And then to calculate kung pila kabuok revers dapat ang gamiton for the beam design, we have NB is equal AS over pi over 4 times BD squared. We have 2.197 or round off to 3. 3 kabuok, 3 pieces na 12 mm diameter for the top bars. So to see if it's safe lang ba na tatlo lang ka bars ang gamiton, we have here for the formula. Since the actual moment, which is 19.39246 kilonewton per meter, is greater than mu, which ang atong mu is 5.244 kNm. Therefore, the design is safe. So ganun lang din for mid-span sa beam, and then for the right span sa beam. So sa top, ang gigamit lang na value tanan is ang negative na values sa moment. And then for the bottom part of the beam, yung sa baba na pod, is ang gigamit po na value is ang maximum moment or yung the positive value sa moment. Same procedure lang, we have same parameters, and then solution to check if it's singly or doubly, and then we check for spacing reinforcement and kung pila kabuok bars ang gamiton, and to check if safe ba ang imong gigamit na design. So same procedure for mid-span and the right span for bottom na beam. Then we have here design for shear. We have input parameters. VU is equals 5.39. Na siya sa tabulation gihapon 5.39. Span 3.7, same parameters. So now let's proceed to the design for shear for stirrups left span. So for beam 21, we have VU is equals 5.39. Nagihapon siya sa tabulation here, shear. And then span 3.7, same parameters for strength, dimension, and rebars. So to see if VU is greater than theta VC, that therefore stirrups are necessary. If theta VC is greater than VU, but it's max, we have here for sheet 1. And then if VU is less than 0.5 theta VC, therefore stirrups are not needed. So for this, makalculate na to ang if ang sa stirrup. So since VU is less than 0.5 theta VC, therefore stirrups are not necessary. So let's proceed to sheet number 3. So money siya. So same parameters. So we have VU is equals 5.393. Then we have that the VC over 2 is equals 14.26. Then we have VUL 4.682. So by similar triangle, we can get VU is equals 4.6817. So yun siya na value. Nakuha siya by similar triangle. So under seismic provisions, maano siya? Makuha natin ang spacing sa stirrups. So therefore, the final design for stirrups is 1 at 50, 10 at 75, 5 at 100, and the rest at 200 mm. So maano siya? And then for the crack width, to check if okay ang design, overall design, crack width. We have for left span sa beam, width of the girder or beam 200 or the dimension 200 by 300, effective depth 260, concrete cover 40, yield strength of concrete or FC is 21 to 75 since grade 40 na rubbers po ang akong gigamit. And then we have the elasticity of concrete and elasticity of steels, and diameter of stirrup na gigamit is 10 mm. Then the parameters for permissible crack width, ano siya? So for top bars and bottom bars, mo siya ang pag-calculate. So since W 0.1356 is less than 0.41 mm, therefore the crack is less than 41 mm, therefore it's okay. So pumasa siya sa crack width. Now let's proceed to column designs calculation. So ganun pa din, the first thing I did is I tabulated these values from STAAD. And then gikuha lang na ko ang PU and the PD, maximum values for PU and PD. So now let's proceed to this. For corner columns, ito siya yung calculation. We have the result from STAAD analysis. PD and PU, makita siya sa tabulation, the maximum values. And then we have LU or ang length, which is 2.7. And then FC 21 grade 40 pa din na reverse ako ang gigamit. So number of columns 6. So these are the parameters for column 1 with depth. So basically dimensions. And then we have inertia. And then for girder 1 and girder 2 na nakakonect sa kanya, we have the value for K is equals 1, E1 is equals this. And then for PC is equals pi squared over pi squared times E1 over K LU, or length squared, is equals 2251.7286888 kilonewton. For summation for PC, or i-times lang siya sa number of column, which is 6 kabuo. So we have 13,510.3721 kilonewton. Then now let's proceed to column designs, column with two connections, since these are corner columns. So we have given column dimension 250 by 250, concrete compression strength or FC, and reinforcing yield strength is FY. Since again, ang akong gigamit ko na value, ay akong gigamit na grade for steel is grade 40. And then we have story clear height, which is 2.7 meters, moment inertia gross, and the K factor 1, since the structure is has a pin support. And the Euler buckling load for column, and total Euler buckling load for all of the corner columns, times lang natin siya sa 6. And then we have here the axis and the y-axis. Dili na siya na tabulation gikan sa column tabulation for PU and PB. For the non-sway and the sway column, gitabulate lang gihapon nako ang maximum and ang minimum values. Gikan gihapon dito ni siya sa STAAD analysis. So to check if the column is slender, K times length over R is equals, if it is greater than 22, then the column is slender. So using moment design equation, the value gikan sa ACI equations 10 to 18. Ito siya. Para to check if the design is safe of being unstable under gravity. And then we have here to check the column design para makuha ang numbers of bars and spaces. So given parameters, ang length is 2.70, PU 35.969, then MU negative 0.008. So we have to use, if 16 mm na bar ang akong gamitan is i-choose na design, is kailangan na ako gamit ng 6 kabuok na 16 mm. We have here the spacing for lateral ties spacing. So same lang din po siya sa pagkuha na ako sa the rest of the column. Now let's proceed to footing designs. So for footing 1, nag-assume lang ko daan na square ang design sa ang footing. So we have here now let's proceed to footing designs. So for footing 1, nag-assume lang ko daan na square ang design sa ang footing. So we have here soil and footing properties. We have cohesion at 15 kPa, internal friction 10, base and length is 1.2 and 1.2. These are the initial design for footings, and then the depth of 1.3. This is from the ground, the bottom of the footing to the ground surface, and then we have factor of safety 3, soil unit weight 16.5, and then the surcharge of dapat ano to is equals times surcharge of 21.45. Now, since we have soil and footing properties na values, now we can calculate for the bearing capacity factors. We have NQ is equals 2.47, NC is equals 8.35, and NY 0.37. So to get the bearing capacity, we have QU is equals 1.3 CNC plus Q and Q plus 0.41 B times NY is equals 218.65 kPa. Then we have Q all is equals QU over Fs. That is 218.65 over 3. The safety factors is equal 72.88 kPa. Now let's proceed to isolated square footing design actual loading moment. So these are the set of parameters that we need to design for to calculate the design for the footing. So we have soil properties, single yung kanina, and I chose bar diameter 12 mm. And then for loadings, galing din gihapon siya sa STAAD analysis. We have here PA, maximum MX, and MZ. So first up is 3.47, MX is 0.24, and then we have MY 5.24, TU is 21.25, MUX 0.30, MUY 5.66, then Q all is equal 72.88, then Q efficient is 49.34. So for the design stability, we have Q efficient is equals PT over B squared plus 6MX over B cubed plus 6MY is equals B cubed. So since we already have value for Q efficient, which is 49.32, ang only unknown na lang sa formula is ang B squared. So to get B, Q efficient is equals 49.39 B cubed minus 3.47 B minus 33.0.6 equals 0. By calculation, B is equals 0.90. So, you round off na to the nearest whole number is equals, B is equals 1 meter, since ang gi-assume nato na design first is square. So B and L is equals lang sila. So B is equals 1 meter, and so is L 1 meters. Then check for the capacity. P all is equals Q all times area. So if P actual is less than, if P actual is less than or equal to P all, then the remarks is okay. So for B prime is equal 0.86, Then L prime is negative 2.04. Then A prime is negative 1.756. So PL is 72.88 times limit is 125. So check for stability. We have Q min is equals PT minus over B squared minus 6mx over B cube minus 6my over B cube. So basically, to see if the footing design is stable. So the design for shear, we have PU is equals 21.25, MUX 0.30, MUY 5.66, base 1, and length 1. So these are the parameters for design for shear. So we have here one-way shear. We have the value for QA, QB, QC, and QD. So is equals for QA is equals PU over B squared plus 6MUX over B cube plus 6MUY over B cube is equals 57 PPA. Then we have QB is equals PU minus B squared minus PU over B squared minus 6MU over B cube plus 6MUY over B cube is equals 53.4. Then we have QC is equals PU over B squared minus 6MUX over B cube minus 6MUY over B cube is equals negative 14.5. And then we have QD here is equals PU over B squared plus 6MUX over B cube minus 6MUY over B cube is equals negative 10.9 kPa. So for one-way shear, nilang gihapon siya for similar triangle. We could get Q1A is equals 31.54 plus 67.92D. So ang kuhaon natin diri is the value for D for one-way shear section 2. So after using these formulas, 0.1 meters. So for sure, pilion lang nato ang mas dako na value, pero since parehaman sila, ug value na na-generate, so ang atong D is 0.1 meters. We have thickness. Now let's proceed to design for flexures. We have the same values for QA, QB, and QC, and QD na gigamit nato sa design for shears. And then to get these values, by using Varignon's theorem, makuha nato ang value sa Q average for section 1.1 and section 2.2. And then let's proceed to the spacing. Using these parameters, we have, since ang gigamit na values, gigamit na space, gigamit na diameter for this footing design is 12, we can calculate na the number of bars is equals to 5. Bill of material estimations. For structural work, class A, lahat na cement ako ang gigamit. For concrete works na siya. Concrete works, cement, sand, and gravels with corresponding unit cost. Reinforcing steel works, lahat ng mga steel bars na kailangan na ani siya diri atanan. Kanina mga values is ang corresponding niya is for grade 40 na grade 40 na price din. Siya ang steel price for grade 40. Minimum yield stress and tensile stress. So for masonry works, we have here the estimated cost. For structural steel works or sa roofing. And then scaffoldings. And then we have architectural and finishes. Carpentry works, Yung sa roofing, ito pala yung sa trusses. Then we have the for ceiling works and tile works. Then for fabricated na nisyalat, the schedule of doors and windows. And then for painting works. And for plumbing works and electrical works, lump sum na lang na siya para mas fix ang pag-estimates. The summary for the billing of quantities. We have for preliminaries, 90,000, site works, 24,523.60 pesos. For structural works, we have 295,840.77. For architectural and finishes, we have 196,067.93 pesos. For plumbing works and electrical works, nakalump sum lang siya is 130,000 and 35,000 respectively. So for material cost, ang overall cost is 771,432.30 plus labor cost na 226,133.29 is equals 997,565.58. So na-apply design and supervision na 8% and the mobilization profit na 10% is equals total cost of 1,177,127.39 pesos. So that's for activity 3. Now let's proceed to activity 4, the project management tools. Let's proceed to activity 4, which is project management tools. So this is the activity network or the activity network for the project construction. So these are the series of activities na kailangan para matapos ang Katoma project. So first is for plans and permits, we have 35 days. Then under site works, we have clearing and graving, site staking, layout, excavation, base course, grading, and backfill. Then under structural works, we have steel bars fabrication and formwork scaffolding fabrication. Then under foundation, we have bed bars layout, wall footing bars layout, concrete pouring and curing. For columns, main bars and ties erection, formwork scaffolding erections, then concrete pouring, curing. Same then under roof beams. Then we have masonry works, HB piling, wall plastering. For slab compaction, steel bars layout, concrete pouring and curing. Roofing works, fabrication of angle bars, truss installation, roofing sheet installation, gutter flushing, downspout installation. And then under utilities, we have plumbing, do rough-in works, do inspection works and finish works, then electrical works, inspection works and finish works, ceilings, joist and stud installation, filling boards installation. And then for finishing works, we have tile works, doors and windows installation, paint works like clearing and do final inspection. So, dali makita ang breakdown sa structure. Breakdown structure sa katuna. Kanina project. So, ano siya is this is the per CPM chart for Halasan residents. Ano siya ang hatong mga critical path for this project. For this video, I hope na masabtan lang ako ang output. So that's all. Thank you.